To start class, go ahead and write these ones down and try them in your notebook. If you need graph paper, go ahead and grab them from the front of the room. Pause this video and give yourself some time to work through these problems and then replay it when you're ready to talk about them. Okay, for our absolute value functions, what we want to do is start by figuring out how this graph moved left, right, up, or down to figure out where the new vertex is. This 4 will move my graph left 4. And the 4 outside is your k value, which will move it up 4. So that means that my new vertex, instead of being at 0, 0, is at -4, +4. What we did after that was we wrote out our t-chart, and we put our vertex in the middle, so -4, +4, and then found points to the left and the right. So say -3 and -2 are both to the right of -4. -5 and -6 are both to the left. You can remember here that the points the same distance away from your vertex will be the same values. So at -5 and -3, we're going to have the same value for y, and at -6 and -2, and you can use that to help you out to solve this. So say I plug in -3. It's going to look like this, where you plug that in for your x. -3 plus 4 is 1. Absolute value of 1 is 1. So this is just 3 times 1 plus 4, which would give me 7, both at -3 and -5. If we do the same thing for -2, -2 plus 4 is 2. Absolute value of 2 is still 2. So this is 3 times 2 plus 4, which gives you 10. So if we plot these points, and this goes off the graph, we can approximate it. Oopsies. This is what our graph should look like. What I think every time, remember, is I've decided if this looks like what I expected it to. This was moved left and up, and it's skinnier than our parent function, which is good. Lastly, what you want to think about is your domain and range that we added on last time. Your domain is the x values that you're allowed to plug into your function for all absolute value functions. Remember, that's all real numbers, so it's -infinity to infinity. Your range is the y values that you get out of your function, so it's the bottom to the top. The lowest point on my graph is here at the vertex at 4. Inclusive, because you can get a 4 out of your answer, and it goes up to infinity. So that would be my domain and range of that function. On the quadratic function, you started out the same way. You figure out how it moves left, right, up, or down to find your vertex. This one goes to the right 3 and up 4. So my vertex is now at 3, 4. We'll make our t-chart again with 3, 4 in the middle. You plug in 2 to the left and 2 to the right, so 2 and 1, and 4 and 5. And again, we just have to plug in either 2 or 4 and either 1 or 5 because it will use that axis of symmetry. If I plug in, say, 4, you're going to do 4 minus 3 is 1. 1 squared is still 1, so this is -1 plus 4, which is 3. And then if we plug in 5, 5 minus 3 is 2. 2 squared is 4, so this is -4 plus 4, gives me a 0 for those. Remember to curve your quadratic function. It should not be a V. And that's what my graph would look like. It is upside down, which is good because it was negative here. And then the 3 did move it right and the 4 up. And again, last but not least, our domain and range. Again, with your quadratics, it's always going to be a -infinity to infinity on your domain because you can plug in anything you want. On your range, it's bottom to top, so at the bottom, it's going to -infinity. But the highest y value I'm going to get out is this 4 right here. So it's -infinity to 4. You guys do have the homework answers sent to you, so feel free to take a second and talk through any questions you may have as a group and see if you can come to a consensus on any of them. If you need help, feel free to come see me later so we can go over anything you need. Today we're going to talk about graphing piecewise functions. Piecewise functions look a little bit different. We talked about these on the first day, but we're going to make sure that you remember them a little bit first. As you go through this video, feel free to pause it so that you have time to write things down as you need, and then push play again once you're ready to go. Piecewise functions, we defined this on day 1, but I'm going to make sure we remember that, are functions defined by multiple equations over different domains, which remember is really just talking about your x values. An example of this that we saw last time, or first day, is when I give you one f of x, but then I write out like 4 different equations, and I'm just going to make this up. So for this one that I have made up here, if you have an x value less than or equal to 3, you're going to plug it into this top one. If you have an x value between 3 and 6, you plug it into this middle equation. And if I give you an x value bigger than 6, you plug it into the bottom. So for example, if I had said I wanted to know f of 2, 2 is less than 3, so that means it falls into this first region. So I'm going to plug it into that first equation. So we would do 2 squared plus 4, and you would get 8. If I had said f of 5, 5 is between 3 and 6, so we would only plug it into this second equation, and we would do 4 times 5 minus 2, and your answer would be 18. Lastly, if I gave you another one, say maybe f of 6, 6 falls into this bottom region because it is equal to 6, and so you plug it only into the bottom one, which here, since it's just a number, your answer is automatically 7. So we did that together on day 1 of class. Today, we are going to learn how to graph these together. I'm going to give you some steps on this slide, and then go through another example with you. So I'm going to go back and forth on this first one. When you start a piecewise function, the first thing I want you to do is identify where you change or switch equations. And what that means, so if I look at this example, and again, feel free to pause this and take some time to write it down. But if I look at this, it is switching equations at 0, because 0 shows up in my domain over here on the right-hand side, and at 6. Okay, what helps for some people is to draw a line wherever it switches. So you can draw a vertical line at 0 and at 6 to know that you should have different equations, because these are going to look pretty different than anything you've ever seen. What we're going to end up having is an equation graphed over here and a different one graphed in the middle, and then a final one graphed over here. So I'm going to have 3 different equations for this one because I have 3 different parts of my piecewise function. So I first identify that. Then you are going to create a T-chart for each section and graph them. So I will kind of color code this to help through. Okay, the first one we're going to graph is if x is less than 0, and so I'm going to draw one T-chart here. And what I'm going to do is I'm going to pick only x values that fall in this region. So anything from 0 on over to negative infinity is really your options. But I'm going to stay within those bounds. So 0, maybe -1, -2, -3. You can start with a few and then see if you need more. And we're going to plug these numbers into this top function. So when we do 0 times -3, we get 0. When we do -1 times -3, we get 3. When we do -2 times -3, we get 6. And -3 times -3, we get 9. So again, I'm just plugging these x values into this top function. And I can plot those points to give myself an idea of what's happening so far. And we are going to actually sketch that. When you do sketch it, I want you to think about your boundary lines, though, very carefully. And here, x is less than 0, which means I technically couldn't really plug in 0 because I can only plug in things less than 0, but we do need to show it on our graph. And the way we show that is just like when we graphed our inequalities and we put an open circle or a closed circle, we're going to put an open circle on 0, 0. So just like your linear inequality, or your, not linear inequalities, but your inequalities we solved last week, where you put an open line, or an open circle, if it was just less than or just greater than. And then we're going to graph it. So this is one portion of our graph. And then we're going to repeat ourselves for the other two parts. So I'm going to make a second t-chart. And again, I'm going to pick things in this region. So I'm going to pick 0. I'm going to pick 1 and 2. I do like to pick each boundary point, so I'm going to pick 6 also. But as long as you pick stuff in here, you're fine. With this one, when I plug in 0, I get -1/2 times 0, which is 0, minus 1 is -1. On 1, I'm going to do -1/2 times 1 minus 1. That's going to give me -1.5. On 2, I'm going to do -1.5 times 2 is -1, minus 1 is -2. And when I plug in 6, -1/2 times 6 is -3, minus 1 is -4. And you can plug in more points as you need. So at 0, we're at -1. At 1, we're at -1.5. And then at 6 over here, we're at -4. So that does give me a line that I can draw. We do need to then think about whether it's open or closed. On 0, it should be closed, so I am going to put and make it a little more obvious. On 6, it should be open though. Then we're going to go ahead and do the same thing for the last one. So you're going to have a lot of t-charts here, but that's okay. And again, I always start with my boundary line and then plug in something to the right, so maybe 6, 7, 8 before it goes off the graph here. We are going to plug these into the bottom function. So we're doing 6 minus 7 is -1. 7 minus 7 is 0. And 8 minus 7 is 1. So at 6, we're at -1. And if you notice, it's going to be an open circle. 7, we're at 0. And 8, we're at 1. And then that's going to keep going forever. Okay, then the last thing you're going to do once you graph these, this is your last step, is you're going to identify your domain and your range. So on this one, my domain is your x values you're allowed to plug in. Okay, looking at this, I am allowed to plug in any x's I want most of the time, but we do have some problems. One hint I will give you is that usually your problems will show up in your domain restrictions here on your piecewise function. If you look at it carefully, 0 shows up in both of them, but it is not included in the first one and it is included in the second one, which is okay, which means I can plug in 0 to my function. What you will notice is at 6, neither of them say equal to, and that's going to be super important. The other place you can notice it is here on the graph. Those are both open circles. which means I can't actually plug in 6. So my domain does have an issue here that we haven't seen yet. With your domain, you can plug in any number you want except for 6. So the way that we're going to write that, you can plug in from negative infinity all the way up to the number 6 is what this first part tells me. But we cannot plug in 6, so I'm going to put a parenthesis there because it's not included. But then you're going to go on to tell me, okay, you can also plug in from 6 to infinity. So what this long statement is saying basically is that you can plug in everything except for the number 6. This U, if you don't remember, is the term for union. It's just a fancy OR. Okay, but it's every number from negative infinity to 6 and every number from 6 to infinity, not including the 6. For your range, this is where we go from bottom to top. The lowest point on my graph is right here. So the lowest y value I can get out is -4. And if you notice, it's an open circle, so it's going to be a parenthesis at -4. Then you need to pay attention and say, okay, as I go up, is part of the graph will eat any of the 3 of that section. So this whole section from -4 to -1 is taken care of by the green one. The red one jumps back in at -1 and goes up forever, and then the blue one's after that. So after -4, there's no issue, so it's from -4 to infinity. Okay, feel free to take a second and try this one if you want to give it a go first, but then I will start to fill in the chart, so feel free to pause and unpause as you need to. Our first step that we said a minute ago was to figure out what your different sections were so you knew where your graph should be. Look at your domain restrictions. So -4 and 2 is where my graph switched, so that's where I'm going to draw myself a vertical lines. -4 and at 2 is where I should see some changes. So I'm going to have one graph over here, I have another graph in the middle, and then a third one way over here. Then we're going to start to make our t-charts. For this first one, you are only plugging in numbers in this far left region. So I always use my boundary, so -4, and maybe -5 and -6. This function is a special one because it just says that no matter what you plug in from -4 to infinity, so any of these over here, you're going to get out a 5. So if I plug in 4, I'm going to get a 5 because there's no x. At -5, it's 5, and at -6, it's 5. What this will give me is a horizontal line at 5. Okay, do remember, think about if it should be open or closed, because this is equal to, it's going to be closed on the line, and then it's this horizontal line going off to the left. If you sneak ahead and look, this last one's actually going to look the same way, except it's going to be an open circle on 2. So we can actually fill that in right now if we want, since those graphs are the same. To get the middle section, again, I'm going to plug in numbers between, so -4, -3, -2, and again, I want both boundary lines, so a 2. We're going to have to see if we need more numbers in there. You very well may. One thing I always think about, we know that this is an absolute value function, so it should look like a V. So we're going to have to think this through and make sure we have enough points as we go. We may add more to that chart. When we fill this in, we do the absolute value of -4 plus 3. -4 plus 3 is -1. Absolute value is 1. At 3, we do -3 plus 3. -3 plus 3 is 0, which gives me a 0 then. -2 plus 3. -2 plus 3 is 1. Absolute value of 1 is 1. When I plug in the 2, 2 plus 3 is 5, so the absolute value is 5. So I'm going to plug those in, plot those, and see what's happening. At 4, notice that it is just less than, so it's going to be an open circle. At -4, 1, 3, and then -2 we're at 1, and at 2 we're at 5, which is actually the same point we have here, so I'm going to go ahead and fill in this circle. If you are unsure of what's happening between -2 and 2, feel free to add more points. Like we could plug in -1, 0, and 1. You can always add more points. At -1, you'll notice we are at 2. At 0, we're at 3. And at 1, we're at 4. So do not be afraid of giving yourselves more points, but also kind of use what you think the function should be. This should be a v, so this is good. So this is our finished graph for this function, and we're just going to go ahead and find our domain and range. For your domain, again, primarily check your boundary lines. As long as you have a closed circle on any boundary line or an equal to up here, you are good to go. And if we look at it, at -4, we have an equal to, so we can plug in -4. And at 2, we do as well. So my domain is -infinity to infinity. For my range, we went bottom to top. The lowest number I can get out is right here at 0. And it is inclusive because I can get that out. It's a closed circle there. And the biggest number I can get out my graph will not go above 5. But that is also inclusive. Go ahead and take a second and give this one a try. And then again, start the video again so you can have me go through it. For our boundary line at this one, it's going to be at -1. Again, because of our domain right there. And I'm going to make 2 different charts. One for the left and one for the right. For the one on the left, what you may notice, and it's great if you do, is that it is another line like we had on the last one because there's no variable here. So all of these are going to give me -4 as an answer no matter what I plug in. So I can draw in this horizontal line at -4 with a closed circle on the at 1, or at -1. Then we're going to go ahead and switch graphs. Again, using -1, even though that's going to be an open circle since it is not equal to here. And then maybe 0, 1, 2, however many you need. When I plug in -1, -1 squared is 1. 1 minus 2 gives me -1. Plugging in 0, 0 squared is 0. Minus 2 gives me a -2. 1 squared is 1 still. 1 minus 2 is -1. And then plugging in the 2, 2 squared is 4. Minus 2 is 2. So I can go ahead and plot these points at -1 at 1, or -1, -1. Keep in mind that's an open circle. 0 is at -2, 1, and then 2 is up here at 2. Do keep in mind what this should be. This is a quadratic, which means it's a U shape. So make sure to give it that same curve. Here, so last time we talked a lot about finding the vertex, and you can do that here. We can find the vertex from the equation, but with piecewise, sometimes it's easier just to make a chart for everything. For our domain and range, so your domain, we don't have any issues because over our restrictions here, one's equal to and one's not. So my domain is all real numbers, -infinity to infinity. Range is a little bit interesting here. So we have values here at -4. And so we can write that in a bracket by itself. Since there's not really a range there, it's just a horizontal line. It's one y value you can get out. Then we have this jump of nothingness. There's a blank spot here in the middle of the graph until you get to 2. So this is going to be unioned with another bracket from 2, since that's the bottom part of this blue, all the way up to infinity. So you can have a range with just one number or a domain with just one number, and we'll just write it with our brackets like that. I have one more in here, mostly because I'm gone and I want you to have plenty of examples. So feel free to give this one a try. I will talk through it to make sure that you have the correct work. So with this one, I'm going to draw my vertical line at 0 and at 4, because that is where, again, my domain switches here. When I look at this, you can start to work smarter, not harder. If you notice, this first one is another one that's going to be a horizontal line. So from on this side of the graph, I'm going to only be at -3. And it is a closed circle on 0 because it's equal to. So you could just go ahead and immediately fill that in if you notice. If you don't notice, there is no shame in making a chart every single time. On this second one, from 0 to 4, so in this middle section. I'm going to plug in 0, 1, 2, 3, 4, and we're going to plug it in to this. The first one is telling me the absolute value of 0, which is 0, divided by 2. 0 divided by 2 is just 0. On this second one, absolute value of 1, oopsies, is just 1 divided by 2. This gives me a half, or 0.5, whichever you prefer. Plugging in 2, absolute value of 2 is 2, divided by 2 is 1. 3, if you notice the trend, we're going to have 3 over 2, which is 1.5. 4 is going to give us 4 divided by 2, or 2. So at 0, it's going to be an open circle, remember? And then we go up little bits at a time, and another open circle over here. What you'll notice with piecewise function, we know this is an absolute value, and it should in theory look like a V, but we are not looking at a portion that looks like a V. If you think about it, your vertex here is at 0, 0, so my graph would be going both directions and make a V right here. So even though we don't see a V in the section we graphed, that's not necessarily a bad thing. It just means we're not looking at the V portion of the graph. Okay, and then for our last one, plugging in numbers bigger than 4, so 4, 5, 6, 7. Plugging in 4 here, 4 minus 4 is 0, squared is 0. This will be a closed circle. Oopsies. On 5, 5 minus 4 is 1, 1 squared is 1. On 6, 6 minus 4 is 2, squared is 4. 7 minus 4 squared is, 7 minus 4 is 3, squared is 9. So we can plug in these. We did expect them to be a curve, so that's good. And I'll just approximate that one. This does show us some of our parabola or U-shape that we expect to see. Go ahead and try the domain and range, and then I'll fill that in as well. For your domain, again, check your points where you change equations. Both of those had an equal to in one of the two spots, so your domain is negative infinity to infinity. For your range, bottom to top, again, we have one of those one value only ones, which is okay. So this is negative 3. Unioned with, find me the bottom. The bottom is 0, you'll notice. We have 1, 0 that's an open circle and one that's a closed. So since we have one that's closed, we can use a bracket on the 0 all the way to infinity, because at least one of the two graphs keeps going forever. Okay. For the rest of the notes, we're going to talk about word problems with our piecewise functions. These are printed out for you, so make sure to grab a note sheet from the sub. You do not have to write down the entire word problem to save you a little bit of time. Take a second and read it, and then unpause the video when you are ready to go. For this one, first off, what I would figure out is what your cost is changing based on. So our function here is going to figure out our cost based on the number of days that you have a car. So our x is our number of days, and then our y, or our function, is going to be the cost that you are paying to rent the car for those days. So we're going to write a function for this, f of x. There are two different stipulations, so one if you have it 3 days or less, and one if you have it longer than 3 days. So we're going to write both of those. If you have the car for 3 days or less, meaning x is less than or equal to 3, you're going to pay $45 flat fee to rent that car. One thing I do want to point out, you're not going to rent a car for 0 days, so our x will also be bigger than 0. For longer than 3 days, so if x is greater than 3, they're going to charge us that flat fee and then an additional $10 per additional day. And this is kind of the tricky part to figure out, so I'm going to write some work off over here to help you think through this. No matter what, they're going to charge you the $45, so that flat fee is still here. But they're going to add on $10 for every day past 3 days. So for example, at 4 days, they would do 45 plus 10. For 5 days, it would be 45 plus 20 for those 2 additional days. So we need to multiply this 10 by our variable somehow, but we do not want to just multiply it by x, because then it's going to charge me the $10 for every day and not just the days past 3. So we need to remove those first 3 days from the equation. The way we remove that is by doing x minus 3. When we do this, then we can distribute, and this will be 45 plus 10x minus 30. And combining like terms, we get an equation of 10x plus 15. That's going to be your first part of this. After that, your job is to graph it. What I would do is think about what each axis is. So our x-axis, we already decided, was our days. Our y-axis is our cost. And we need our axes to be labeled with something that makes sense, the numbers. So for my numbers of days, we're talking about pretty solid numbers. So up to 3 and then bigger than 3. So I'm just going to use 1, 2, 3, 4, 5, 6, and so on. For our vertical axis, we are paying $45 or then increments above it. So if I did this by ones vertically, you would run out of space really quickly and you would have to count up to 45. So what I'm going to do is just count by 5. So I'll do 5, then 10, 15, 20, and so on. You do not have to use these same numbers. Make sure you pick something that makes sense. And I'll show you a different way to do it on the next one. 60, and so on. Okay, to graph it then, I'm going to, just like we did before, mark out my point where it should change. So at 3, I should switch graphs. For the first part, let's see, I have an open circle. It's 45, so it's going to be a horizontal line. It should be a closed circle on 3 and an open circle on 0. Again, because it is not inclusive on the 0 and it is inclusive on the 3. For the other part, since it's an equation, I'm going to go ahead and make a chart. I'm going to use maybe 3, 4, and 5. If I plug 3 in for my x, 10 times 3 is 30, plus 15 is 45. Plugging in 4, 10 times 4 is 40, plus 15 is, 55. Plugging in 5 is 50, plus 15 is 65, and that gives me a few points I can plot. You can keep going if you need more. So at 4, I'm up at 55. At 5, I'm up at 65, and that gives me my line to graph. You will notice they met here on the line, which, won't always happen, but it is a nice thing when it does. So this is my graph of my piecewise function. Over here, they want you to evaluate. You'll notice these two problems actually show up here, but they may not have, so you just want to pay attention to that. If we're doing f of 3, though, you would plug it into your top function, the 45, so that would automatically be $45. F of 4, you would plug into the bottom function because 4 is greater than 3. We already have the number, so I'll just write it down, but it was 55. Feel free on the second one, you can either start it with the video paused and then push play to listen to the explanation, or you can just go on into listening to my explanation of it. So we have a place offering their services for venue and food. If I have up to 15 guests, they're going to charge me $200. And then if I have more than 15 guests, they will charge me $200 plus 5 for every additional. So that means that my X here, what it's based all on, is my number of guests, because that's where they're changing it based on. So I pay $200 as long as I have up to, oopsies, wrong way, X is less than or equal to 15. It is going to be bigger than 0. Again, that's kind of it's just assumed because you're not going to have a party for negative people or for 0 people. For X is greater than 15, we have another additional cost one. So we're going to do similar math to before. $200 is the base fee, plus 5 for every additional guest. So X minus those original 15 that are included. If I distribute this, 5x minus 75, so my equation is 5x plus 125. Then we're going to go ahead and graph it. Again, think about your axes. On the bottom, we're talking about guests. And over here, we're talking about the cost. My guess, is floating around 15. So you could count by ones, you could count by twos. I'm going to count by fives. So I'll put 5, 10, 15, 20, 25. Again, this is not the only way to do it, but that's one way to do it. Vertically, though, I have a different issue. So it costs a minimum of $200 plus then an additional 5 beyond that. So what I'm going to actually do is a trick you may have seen in Algebra 1, where you draw like a little squiggle at the bottom showing that you're skipping a portion of the graph, and then you start at whatever number is really relevant. So I'm going to start at 200 since I know that's my base fee anyways. And then maybe I'll count up by fives. So then this would be 220, 230, if I'm skipping lines, 240, 250, and so on. To fill in the numbers then, again, I'm going to draw in my line. So at 15, I should be switching equations. So I'll just draw in this vertical line there. It is $200 originally, so we'll draw that in with an open circle on 0 and a closed circle on 15. To get the values bigger, I can plug in, I'm just going to use numbers that are on my axis. So I'm going to use 15, 20, 25. You can use whatever numbers you want. At 15, it's $200. If we plug in 20, we're doing 5 times 20 plus 125 gives me 225. And plugging in 25 will give you 250. So again, at 15, it actually matches. That's good. Doesn't have to, but we'll let it be matching there. 20, we're up at 225. And 25, we're up at 250. So this, whoopsies, sorry there, is what my function would look like. Then it'll usually ask you to tell me how much it would cost for a particular number of guests. Again, you'll notice these numbers actually are straight from my chart, so we already know them. But you may have to evaluate anyways, or if you didn't use those numbers, you would just plug them into whichever function is appropriate. This video will be on Canvas for you to have access to, so make sure if you need help, you're looking for it there, or feel free to come see me so that I can help you out.